explaining. So basically, think about that. Like, you remember we used to be a ChatGPT, right?
Mm-hmm.
I will record nothing. I will record myself.
Okay.
So there used to be first version of ChatGPT, and you essentially consult with it architecture-wise because it cannot really fix the code.
Mm-hmm.
It was kind of book smart, but not engineer smart.
Yes.
After that, it essentially glorifies Stack Overflow. The second stage, when it became already good to give you a snippet of a code, you start consulting, it's like, hey, copy paste your code snippet, and it's like, can you find a bug? Right, this is already good because it's able to spot some issue which you're able to spot, but you kind of spend less energy for it. But all engineering done by yourself. You have to do it. Third came when context window became so big what you're able to essentially direct it to your code base. You don't need to copy paste snippet, but you're able to, hey, go to my code base and read the code and tell me maybe architecture you can suggest, or maybe you can fix some bugs. This is good. After that, around maybe Opus 4.5-ish, like November last year, it became possible that the agent not just give you the suggestions, but also write down code from scratch which compiles, which is different beast when it just gives you suggestions. Before, sure, it can pull you some code that it might work, but it cannot build coherent architecture. November and a 4.5 Opus was the first which able to build, and you have a hypothesis, hey, if it's able to build from one prompt a whole code base or able to modify code base to the next, can I just keep it in a loop? And it's like, yeah, let's do it. And it became, well, Claude appears like as a little like an NPM style project. So it's essentially able to code you in a loop, and it became agentic programming. Since November, it became essentially de facto programming way because you don't program yourself anymore. You tell someone else, essentially delegate like your employee what to program. It's entirely different paradigm. And there are a lot of ways how you can do it effectively because there are certain things how you prompt it, certain things, but bottom line is as efficient as your so-called harness. Harness is essentially kind of environment where this agent lives, because agent by itself is very non-opinionated, it can hallucinate a lot, etc. So you need some sort of a workflow, essentially, which is able to tell you binary, is it good work or is it not good work? Ideally, some sort of a QA test line, etc. Best way which human invented so far called test-driven development. Test-driven development, everyone claims what they know what is it, but essentially nobody use it unless you enforce it as a harness. Test-driven development, what you write test first, run your code on those tests. Be sure that all tests fail, because if tests not fail, you cannot say that your feature is implemented because test already passed. All tests, it's called red testing. And when you have a red test, good, you stage them, it means you make them immutable. They already like in your Git stage. You do not commit them, but you stage them. You program after that and try to build. You can do a lot of optimization here for quality usually. Some people do optimization for a cost, but because both Claude and OpenAI subsidize currently at June 2026, it doesn't really make sense to do it cheaper. Future, after IPO or immediately before IPO, when we're going to charge a lot, maybe it will make sense, but not right now. And how you can improve it? One of improvement came from actually Boris as the author of this Claude code. Free cops. Basically, free policemen. What they do is what I explain you. Like, there are stages, and on one stage, when you write this test or write down your code, it does not immediately say, yeah, I'm done, and do git commit. What it does, it goes over a committee, and where a free agent, independent sub-agent sits, and it's like, I would like what test coverage is good. So it's a policeman which police what test coverage is good. Second one, it's trying to say what test is not test where your code is coherent with previous code base, because it like to reinvent a logger system a lot, like to reinvent different features, and when you have a lot of repetition, it gets confused. Because when it's grab code base, you just seeing a lot. It doesn't like complex code base. And the last one is minimalistic, because you might notice that when you apply it AI for a code base which is already massive, quality degrades. It does not understand well, it contributes not very well. So there are researchers, you can pull it, you can research it yourself. double check me, but what I found tells that ideally code have to be in very small files, no more than 350 lines. And you shouldn't have a lot of nested circles, nested loops, so 4 inside of 4 inside of 4. AI doesn't understand it very well. And you have to have ideally isolated vertically sliced architecture. Basically, usually when you, let's say mobile application or whatever you program, usually you have like horizontal layer, logic layer. You have a data layer, you have a business logic layer, and you have a view layer or something in between. It's all good for a human because you classify it, but for AI it's complicated. AI works better with something closer to microservices actually, where you have an isolated little piece of code which has everything in it and it's able to understand it completely.
Model based.
You can say it that way. And also when you have this architecture, by continuation you would like to have a minimum relation between this model. You would like to have interfaces be as simple as possible, as restful as possible. It means you don't keep the state inside of this. And you would like to be sure what you can just test one model and afterward use it as a building block referral just by the name. So ideally you don't need also docs, you need self-documented thing. But they are already good. It's usually write down such variables that it actually makes sense when you read them. And when you have it, you say, okay, sure, I have this agent, it's programs for you. But you might notice what you're doing as a developer every time. You just program same stuff. Do this, make no mistake, run this. So you essentially became a monkey. You just copy paste stuff versus like you do a lot of repetitive work. So the current best practice when you do repetitive work is to do skills. Cloud skills or codec skills doesn't matter. So basically if you do something more than twice a day, it has to be a skill. And you do this skill and okay, great. But you might notice I mentioned something about cops, which I mentioned specifically it's a sub-agent. Why do you want to have a sub-agent? What value is that? Turn out this LLM work better if you do not use context a lot. So basically quality of logical and essentially IQ drops if context window is used. So basically the more data you put, the less smart AI is.
Oh, okay.
So basically there are terms which call context window where usually like either 250,000 or like 1 million tokens. At measuring tokens, think it as a Chinese character. It's basically a syllable, might mean a separate word, but doesn't matter. Point being, if you have already a lot data, like your chat history is long, it starts underperform. So usually what you do, you compact. Compact doesn't do magic, it literally reads your code several times and trying to give TLDR, kind of like a summary, remove everything and put summary at the beginning of a context window. It's exactly how it works. And you might notice, okay, if context window is important, can we do something about that? Turn out yes, because when you run sub-agent, you essentially run the new session, new chat, put where only what is needed, and it runs and return your results. So in that way, sub-agent perform better if you would do it in the main flow. And you might notice, hey, if sub-agent is great, why do I do everything with sub-agent? Why I don't run like a main orchestrator, which run manager, which run sub-agent? And it's you came to loops. Basically, what you start noticing that you essentially, there are two things. One of them is agentic development and like this type of orchestration of multi-agent, which kind of work persistently and speak of each other. And another one, loops. Loops, basically, you would like to do everything on a cycle. Usually, you do not limit it to one feature only, or one bug fix only, or some kind of test performance benchmark only. You're living within a bigger organization, which have a bigger process, which have a bigger picture in mind. You would like to serve purpose of your client. Someone like a product have a vision of a product, and you have someone who cut your vision into milestones, and by one milestone a project manager, okay, so we have this milestone, how do we split it into tasks? How do you split it in user stories? And you play like poker, estimate what this is important, this is less important, you have a backlog. So you usually have plenty of data and you have an end goal. So a lot of this is monkey job, which can be automated because LLM is absolutely great at summarizing text, better than a human already. And you might notice when you have a final vision and if you have a very precise, you're able to give LLM and it's able to give you tasks. And sufficiently smart LLM able to essentially do project manager job quite well. And when you have already a task and you have a coherent picture of how your end picture look like, you're able to feed this task into the agents, which are able to perform, able to test, and you're able to move forward. The problem is code base degrade a lot. and were very, very, very difficult for AI. Essentially, best way which taught me how to work with AI is imagine AI is blind. Completely blind, doesn't see anything, but it's able to hear and able to speak. It does not hear and speak per se, but token input and token output are closest to hearing and speaking. Is it cannot see a shit. What it can do, it can call tools which are, well, hey, can you take a screenshot of the screen and tell me what you see in the screenshot, and it returns text and reads this text. You can think as here with text, so it's a blind stuff. So weak point is not complex logic, weak point is something visual, because it's absolutely terrible at something visual. And until we have LLM, we have only workarounds it. So your harness have to have very good QA framework about visual part. Otherwise, it just doesn't work, it will break and stop working. In our thing, you have to have another fourth code, which is actually trying to degrade the code. Essentially, it's called code smell. You might notice what I think is called linter, which usually like
we keep.
say, your line is too big, you have to keep 80 characters per line. So this is part of a best practice, how your code should ideally look like, because we humans know what its code doesn't look like. Chances are people don't care about that. People don't pay attention what doesn't look pretty. So the engineering term is a code smell, there are different practices. In linter, essentially check code smells, but in very, very simple heuristic. There are more complex stuff, and LLM gives us more powerful tool. You can give LLM, fresh LLM, hey, can you check a code and verify what are best practices and doesn't follow, given what you have a table of best practices. It can be complex, it can be human readable, but not program readable. AI is smart enough to figure out. And when it smells code and says, you know what, kind of too many models, very difficult. I don't understand. Agent able to get this. So it's very important to pass these code smell checks as well as coherence to a bigger picture in order to do. And in these, if you do these loops and harness correctly, it's claimable what you're able to do ridiculously complex projects, absolutely mindlessly complex projects. But we are not quite yet there where you can tell, okay, I would like to have an app that does this, and it just works, because per project basis, you have to do harness, and if you don't know how to do harness, chances are you know how to do harness if you spend hundreds of hours of building it. There is no way around. I don't know simple way around that, but maybe it's going to be next frontier, where like Frontier Labs going to offer us a harnesses as well as a QI frameworks, because a Playwright, for example, like you have a essentially browser that you can hear what it's doing, like AI can read. It's kind of like hacky way to do that. But regardless of what you're doing, harness is the most important stuff, because we already have AI which is smarter than human in a lot of ways. And this Flabo, Flabo 5, I tested in an X high effort. It's also tested max effort, but it's just ridiculously expensive in terms of a token usage. And it's able to find bugs which no Opus nor GPT 5.5 weren't able to find by themselves. The weak thing, because I use it in Orchestrator, so basically there is a Claude programs, but it's kind of not programs, it's a manager, and it's called subagent to program, and there is a committee to kind of see a quality, and there is also a committee of GPT 5.5, because it uses a little bit different perspective. Think as a different culture, like Russian versus Chinese versus Americans. There is also Gemini, but Gemini kind of degraded quality, but ideally you would like to use all three of them, because they give you a little bit different picture. And when you have this orchestrator, it performs better than any of these by themselves. And I did not have enough time, I tested only 5 hours of this Flabo, and so far it is significantly smarter than Opus, but given what Opus wasn't able to find the bugs which Orchestrator with Opus was able to find, because there is a mix of different perspective, I assume what Flabo also will not really suffer, but will expect the same kind of feature, so it will work better in Orchestrator with Codex as well as Gemini, then it would work by itself. But beware, it's expensive. I don't think it's possible even to use it in Cursor, because think is currently Claude and Codex, which is from ChatGPT, subsidize you. So basically, if you pay, let's say, $20, you're able to use something like $800 worth of tokens easily. In ChatGPT, probably about $200 a month if you pay only $20. But tariff of $100 give you the same ratio, but $100 of $200 a month give you 2x multiplication. So basically you have even more subsidizing. Essentially you pay 5%. Like if you use it a lot, you pay you can pay as little as 5% of token worth. So when I use $200 a month, I easily use like free $5,000 worth of tokens. And it makes sense to use them all because they give it to you. So there are certain things what you can do it by yourself. You can do it cheaply. You can think and program it. But if I have this amount of a token just given me by Anthropic, it's actually faster for myself to use more brute force solution. When AI works and like figure out like 5 different solutions and I discard 4 of them and take only one. Yeah, one also important thing, the code became disposable because AI routes it and AI is relatively cheap. You don't write as you did before. How you did before? You write down stuff, it doesn't work, you're trying to fix it.
Yeah.
It doesn't work again, you're like, fuck, oh, I'm so tired. You do tomorrow, you just take a cold shower, you write down on whiteboard, you really try hard to understand what's went wrong, and over with some effort, you write it. But sometimes you're so tired, but fuck it. You scrap it and write down from scratch and it just works. There are some cases like that. With AI, it's almost certainly, if it doesn't work after a couple of prompts, you just scrap it and try again. Because you don't write it, AI wrote it. You can even use the same prompt if maybe say, hey, get some, also reflection part, or part of my orchestrator. So if you write down something, like, and it did for your work, and you say, what, here's the issue, it's data for reflect. It means AI did not, either you weren't precise enough to your task, or AI failed. If AI failed, it's able to reflect how it failed and able to auto-learn from it. So essentially it does automatically. As soon as it sees what I give some feedback, which actually duplicates what I tell before at any point, it's reflect. And it write down in the reflection, so it have a reflection log, so it never forget what it ever reflect. And also it update with cloud.md file, so it's kind of like learn how to do not do this mistake. It never commits without claiming what it tested. It always run a full test coverage and stuff like that. It helps a lot. I think more or less it, but again, disposable code, you can write down, AI write down for you like free version or like usually 2 is enough and you choose one which works best and dispose another. A disposable code. Just see which performs best and dispose. And you have this in a loop, so you're able to do it better and better, and you can also leave it at the night because you have a 5-hour Kyoto, and you have to use it twice a day in order to max out your week. And if you really would like to max out and you understand, okay, I still have some Kyoto left, you just run it at the night to some sort of refactoring. It's like, hey, pull from internet best practices for a project like mine, choose information from some 10x developers like best developers, do refactoring, consult with Codex, consult with Gemini, make no mistakes. Last part doesn't really work, but point being, I speak, I don't even type. I use WhisperFlow, so it's faster to speak than to type, and it works at night, so you just go sleep at the morning. Usually it's a garbage, but sometimes some of these commits he made, it's actually you're able to cherry pick, not you, but AI with fresh prompt, with fresh context, able to cherry pick, and essentially it's a salvage, it's called it. So it's have a whole kind of git of a salvage branches, which essentially he pick up something useful out of it. And sometimes it's useful, sometimes it's not, but you lose a few seconds of a prompt. It's definitely cheaper when you ever do it yourself.
Yeah.
Do you have any questions?
Okay, so that's a lot of information to digest. I see that the things that I have been thinking about is how much its process will take it, by going from normal flow that's basically just doing one thing to have this loop and orchestration. Like, doesn't it cost a lot of money? Is it worth it to do it that way?
It's almost certainly worth to do it. In terms of any cost of API is cheaper than your time as developer. This is very important thing to understand. Second, orchestrator doesn't take significantly more tokens. It takes same amount of tokens and probably less. As if you, after it didn't work, say, hey, fix this, fix that, test coverage is not good. So, and last one, it essentially automate your workflow how you would do it. So you automate your work, not AI work, if you think about that. Because if without this workflow, you essentially would do the same. You say, hey, write down my test. Hey, run down subagent with a free like context window, but see it, from point of disagreement. Also, in my particular orchestrator, it have a pre-prompt of disagreement. What it means? By default, you might notice what LLM is very agreeable. I don't know why hypothesis, because it's studying coherent text, but usually go like in a flow versus blah blah blah, but and go. So for AI, it's from training data, it's easier to agree by default than to disagree. And therefore, if you say, hey, can you find the bugs, will work sometimes worse when you say, there are 3 bugs in this code, like 1000%, there are 3 bugs, so find them. And because of this pre-prompt, like it's trying to find, and it will higher chances what it find more bugs when if you say, are there any bugs here? So you see, it just works, but because how LLM works, it's a little black box, not a little, it's quite a big black box for us, like humans, because we know what does it do, because we program it, but we also know how brain works. We know the electric chemical activity, and by this knowledge how each part of brain works, because we saw it in microscope, we have no idea how consciousness works. A little bit same with LLMs. We know how it's made because humans are made. You see a source code, but we have absolutely no slightest clue right now how is it even able to do that good work, because it just predict next character, nothing else.
Yeah.
So, and by this point, we don't know, but we only kind of test and notice what when you pre-prompted in such way what are 3 bugs in this code, find it works better empirically when you pre-prompt it with different question. Did I answer your question?
Yeah, good answer. Yeah.
Also, it requires a little meta shift in terms of how you program, because if you program many years, like I have 20 years of programming experience, it was a little bit complicated first to kind of give up writing code myself, because it's all I know.
Yeah,
and,
wired already.
Yeah, but there are, like, it's probably a long video, there are a whole bunch of things that people get into kind of typical troubles, I would call, from vibe coding. A lot of people over-engineer architecture and have a habit of, optimizing infinitely refactor architecture because it became kind of dopamine loop by itself, instead of delivering feature which makes matter and, serve customers. A lot of stuff related to non-technical people really like technology because they start hearing words and think they understand, and many of them understand technical stuff. And I noticed that people who came from non-technical background really like to speak about, I can Postgres, and this, and there is like Kafka on top. That's like, I never hear of it from developers who explain what they build. They like not focus, it's like, who cares what database you use?
Yeah.
But people who came from non-technical background, from markets or whatnot, they really like to give these terms. So what it tells, what they really, over-focus onto this technicality, which not as important. AI will figure out what database you use, like, who cares?
Yeah.
And people who are like developers really like to, over-focus on architecture, like myself. I optimize architecture so much, and it's like, it works that way, it does this, like, who cares how it works? Everyone cares what does it do, what value does it bring.
Yeah, what value it brings to the table.
Yeah, exactly. So it also helps to kind of change the mental shift from if you're a developer to become a product builder. I became an entrepreneur of you. And if you're already like not developer, to do not become one. Not really important what the hell going on in terms of technology and stuff. It is important to see a big picture. Big picture essentially of timeline. And also it's very addictive because you feel like you're moving forward. And if you see it from a bigger picture, it's like time flies, but you did not deliver anything on prod. It helps to focus on video demos. That's what I do, for example.
Yeah.
For me, I record video before and video after, and I do like this before-after video every day for every project. That helps me to kind of understand where I'm moving, because it's very, very easy to get on rabbit hole for optimization, something which doesn't matter.
Yeah. Okay, so I think this is a really great point, and the main problem that might happen is that because it's super fast, like what you say, like we might go to the wrong direction super fast also.
Yeah, I couldn't get into some project, but again, Git helps to just, I understand what I, like, two things. One of them, if you don't have a clear goal, it will always steer away because you don't know where you're moving. So have a clear goal and clear time timeline with milestone is extremely important, because like better done than perfect plan. And if you do good enough work first, maybe if you have a time you can optimize, but at least you reach milestone. The most common mistake I've seen, people don't have a clear vision what they would like to build, and it's not written down explicitly on the MD file. It's like they play around, they're here and there, they don't have a clear picture what they would like to have as MVP. If you have it, you have a milestone, you're unlikely gonna steer away. But if you don't have a goal, like how you cannot meet your goal if you don't have one? You'll just work in circles, and you can over-optimize something which afterward you will question, why did you even start building? What am I building?
Yeah,
Why?
exactly.
Yeah, so it's good as a habit to build your orchestrator, because in order to untangle this mess, you will have to build good orchestrator. It's why I think my orchestrator is efficient, because, well, I have to untangle this piece of crap code, but I end up in this because I didn't have a clear enough vision. I think 25 minutes is enough for this. Hope it helps.